Hi students, welcome back to this YouTube channel Bhosle IIT-JEE Academy. Subscribe this channel and don't forget to click bell icon to get notifications of more upcoming videos. Also, you can like this video and share these videos to your friends who are preparing for engineering entrance exams. Today we are going to complete fifth part of this binomial theorem and its simple applications. So let's start with these two MCQs. Here in the first, we have to find the value of this C2 plus 2C3 plus 3C4 plus dot 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 plus 14C15. For that, we will copy this given expansion as it is here. This is 1 plus x whole raised to 15, which is given to be C0 plus C1x plus C2x square plus C3x cube plus dot 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 plus this C15 x raised to 15. And we don't want the term of C0 here, so get this term in left hand side. So this will become 1 plus x whole raised to 15 minus C0, which is equal to C1x plus this C2x square plus C3x cube plus dot 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 this plus C15 x raised to 15. Again, we don't want the term of C1 as well, so let's divide throughout by x and we will take the derivative so that it will be C1 and the derivative of C1 will be 0. So, and as the value of this C0 is 1 and this is 1 plus x whole raised to 15 as it is, and as I was telling, we have to divide throughout by x, so here that whole LHS upon x, and here also it will become C1 plus this C2 simply x, and third term will be C3 x square plus dot 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 plus this C15 into x raised to this 14. So now we can take the derivative on both sides. So here we will write differentiating with respect to x, we get. So here we will use the formula of derivative of this u by v, and the derivative of u by v is v square, this v into derivative of this numerator minus this u into derivative of this denominator. So this formula we are going to use here. So here first we will write this x as it is, and we will take the derivative of this numerator, which is 1 plus x whole raised to 15 minus 1, and again we will put minus sign here, and this 1 plus x that whole raised to 15 minus 1 as it is, and the derivative of this x is 1 and that whole divided by the square of v, that is here x square, and here in right hand side it is going to be 0 plus this c2 plus this c3, sorry it is 2c3 x plus dot 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 plus lastly it is 14c15 that x raised to, it is going to be 13. So let's simplify it. So this x as it is, the derivative of 1 plus x that raised to 15 is this 15 into 1 plus x whole raised to 14, that of 1 is 0 minus this 1 plus x whole raised to 15, and this is minus minus plus, and that whole divided by it is x square. So this is simply c2 plus 2c3x plus dot 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 plus this 14c15 that into x raised to 13. So this will become 15x that into 1 plus x whole raised to 14 minus this 1 plus x whole raised to 15 plus 1 that upon this x square as it is, and lastly this c2 plus 2c3 x plus dot dot dot, this is 14c15 and that x raised to 13. So let's put the value of x to be 1 to get the result. So put here x is equal to 1. So here some part we will do it directly. 15 ones are 15 and this is 1 plus 1 is 2 and that 2 raised to 14. So this is simply 15 into this 2 raised to 14. I repeat, this is 15 ones are 15 and that into this 1 plus 1 is 2, 2 raised to 14. Same here, this is 1 plus 1 is 2, 2 raised to this is 15, and plus this 1, that whole upon this is 1, so we will not going to write the denominator. So here in right hand side it is simply that C2, this is 2C3 plus dot dot dot, that last term is going to be equal to that 14C15, as 1 raised to 13 is 1. So look at this left hand side. So we can take this 2 raised to 14 common, so from the first 15 is left, minus 2 raised to 15 is nothing but 2 raised to 14 into 2, so that 2 is left, that plus 1, and right hand side remains as it is. So 15 minus 2 is 13, so this is 13 into 2 raised to 14 plus 1, and that is equal to this C2 plus 2C3 plus dot 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 plus this 14C15. So this is the expression whose value we were looking for. So its value is 13 into 2 raised to 14 plus 1, that is option number B is correct. So let's continue this second MCQ. Here we have to find the value of this summation NCR upon NCR plus 1 plus NCR plus 1. So for that, where R is from 0 to n minus 1. So let's copy the same here. So this numerator is NCR, this NCR plus this NCR plus 1, where R is from 0 to n minus 1. So we will use the formula which we already have studied, this formula in a regular 11th standard. So this NCR as it is. So we have this formula, this NCR plus this NCR plus 1 is always equal to this n plus 1 CR plus 1. For example, if we are having this 6C3 plus this 6C4, so the same can be written as, so the R which is greatest one we are going to copy it as it is. So here 4 is greater than this 3, so here those two values of R should differ by 1 and the value of n should be same, then only we can apply this formula. So we have copied the greatest value of R, and here the value of this n is to be increased by 1, so that will become 7. So similarly here also it is NCR plus 1 is nothing but, here I increase n by 1 and I took this R which is greater 1. So here denominator will simply become that n plus 1 CR plus 1. So this is the formula that I used, and where R is from 0 to n minus 1. So again let's continue. So here R is from 0 to n minus 1. Again numerator we will keep it as it is, and in denominator again we will use one more formula. So that formula is NCR can be written as, I can take this n by R as it is, and for that I have to decrease the value of n by 1 and I have to decrease the value of R by 1. For example, if we can write this 100C91 as this 100 by 91, and that is into this 100 is to be decreased by 1, and this is 99C, and this 91 is again to be decreased by 1, so this is 90. That means this 100C99 is always 100 by 91 times of this 90 sorry. So similarly here also this NCR is n upon R times n minus 1 CR minus 1. So whatever this n plus 1 and that R plus 1, that we are going to copy it as it is, and as per the formula we are going to decrease the values of those two by 1 each. So this will become NCR. So this is the formula again I used here. So here this NCR and this NCR is going to get cancelled. So 1 upon x plus y will become that y upon x in multiplication. So in that way, so this will become R plus 1 that upon n plus 1, where R is from 0 to n minus 1. As n plus 1 is constant for this summation because the variable is R. So get that n plus 1 outside this summation. and we are left with simply summation r plus 1, where r is from 0 to n minus 1. So now if I put the value of r from 0 to n minus 1, let's see what happens. So this is 0 plus 1 is 1, so this 1 plus 1 is 2, so this 2 plus 1 is 3 plus dot dot dot. So the last value of n is here n minus 1, so this n minus 1 plus 1, so 1 1 cancel, so lastly we are left with n. So this is nothing but sum of first n natural numbers, so its formula is always n into n plus 1 that upon 2. So that formula we will use here. So this is 1 upon n plus 1 that into this n into n plus 1, as I said this formula. So here this n plus 1 get cancelled, we are left with simply n upon 2. So this n upon 2 you can see here in option D, so this is the correct option. Let's start these two MCQs. Here in the first, the second term in the expansion of this 13th root of a plus a upon root of a raised to minus 1 whole raised to n is given to be this 14 into a raised to 5 by 2, and we have to find the value of this nc3 upon nc2. So for that, first we will find the value of this t2 or second term. For that again we will use the formula whichever we used many times earlier. So that formula is tr plus 1 is equal to ncr into x raised to n minus r into this a raised to r. So here, as we wanted to find the value of this t2, so let's put the value of r to be 1 here. So this will become 1 plus 1 2, and n is not given, so the value of r I was telling as 1. So here the value of this x is this a raised to 1 upon 13, a raised to 1 upon 13, and that whole raised to, as usual we write that as n minus r, that is here n minus 1. So here the value of a is, so let's simplify it here. So this is a upon a raised to, this is minus 1 by this 2, this is minus half. So when we subtract those two indices, so that will become 1 minus minus plus half, that is it is simply a raised to 3 by 2. So here the value of this a in this formula is a raised to 3 by 2, and that whole raised to this 1. But the value of this t2 is given to be this 14 a raised to 5 by 2, which is equal to here 14. The value of this 14 c1 is always n. So let's simplify it. So this a raised to this n minus 1, that whole upon 13 we can write. So this is n minus 1, that whole upon 13, and this a raised to 3 by 2 and the 3 by 2. And so there are two ways to compare the, so either we can compare this coefficient of this a raised to 5 by 2, and here that coefficient is n, or we can simplify those two terms and we can compare the indices of n. So first we'll simplify those two indices of n, and here it is n minus 1 that upon 13 plus this 3 by 2, which is equal to 14 into a raised to 5 by 2. So there are two ways to find the value of n here. Either we can compare those two things, or we can compare the indices of a in both the sides. So it is better we will compare this coefficient with this coefficient. So therefore the value of n is going to be 14. So let's find the value of this nc3 that upon this nc2. So this is nothing but this 14c3 that upon this 14c2, and we have this formula. So that formula I am writing here. The value of this ncr upon this ncr minus 1, that is simply it is the ratio of consecutive combinations you can call. So here first we have to take the subtraction of those two things, that is n minus r minus minus plus 1 that upon, so this r you supposed to copy as it is, so that we can see it here in details. So this formula I am going to use here in the next step. So as I said, so this 14 minus 2, so that we will write it here so that you can understand it properly. So as I said, this 14 minus 2 is to be written here in numerator, and in denominator, so this simply 3 is written, and its answer is going to be equal to 14 minus 2 is 12, and that 12 by 3, which is nothing but 4. So from options, this is the correct one. So again I repeat the formula, ncr upon this ncr minus 1 is equal to n minus r plus 1. So the same can be written as this ncr r upon, if I take this nc, or we can take this as r plus 1 also, and that ncr. So here we can take simply this n minus r and this r plus 1 as it is. So this will be also the same formula. So let's continue next MCQ. Here the second, third and fourth terms in this expansion x plus a whole raised to n are given to be 240, 720 and that 1080. So let's write those terms as it is. So T2 is given to be 240, but the formula to find the T2 is same whatever I have written here. So that formula we will use. So the value of n is not given, so this is nc, as we want to find the value of T2. So let's put the value of r is 1, so here x raised to n minus 1 and that a raised to 1, and this is nothing but 240. So consider this as equation number 1. Similarly, the value of this T3 is given to be this 720. So same formula we can use here. So this is nc2, that x raised to n minus 2, and this is a square, and this is nothing but 720. Let this equation number second, and lastly the value of that T3 is given to be, it's T4, 1080, and that we can find it using this formula nc3 and that x raised to n minus 3 and this a cube, which is equal to 1080. Let this equation number 3. So to eliminate x and a from those three equations, let's multiply equation 1 and 3 and divide that product by square of equation 2 in LHS and RHS. I repeat, to eliminate x and a from those three equations, we have to multiply those two equations, that is equation number 1 and equation number 3, and to that product we have to divide the square of equation 2, that is LHS and in RHS. So let's do the same. So first we will multiply LHS of equation 1 and LHS of equation 3. So that will be nc1, that into x raised to n minus 1 into a, that into this nc3 into x raised to n minus 3 into a cube, and as I was saying, we have to divide this LHS by square of this LHS of equation second. So this is nc2, that into that x raised to n minus 2 into a square and that whole square. So same thing will be there in right hand side. So multiplication of right hand side of equation 1 and 3, and to that product we have to divide the square of right hand side of equation 2, that is 720 square or 720 into 720. So let's simplify the same. So here first we will write this nc1 into nc3, and that x raised to this n minus 1 and this n minus 3 is x raised to 2n minus 4, and this a raised to this 3 plus 1 is 4, same in the denominator. So this nc2 we will write it twice as its square is there, and this x raised to 2n minus 2 to the 4. So this is 2n minus 4 and that a raised to 4, which is equal to, so this 24 or 240 ones and 243s, and this is 3 ones and this is 360s, and this is 360 ones and this is 362s. So the right hand side is simply half, and this x raised to 2n minus 4, 2n minus 4, this a raised to 4 and a raised to 4 gets cancelled, and we are left with simply, so first we will write this as a first part, that is nc3, that upon this nc2 and that whole upon, so we will get this term in the denominator of this nc2, that means here it will become nc2 that upon nc1. I repeat, so we have written this nc3 upon nc2 as it is, and I took this nc1 in the denominator, and that is equal to simply half. So again we will use this formula whatever we used here, so remaining part we will write here. So this nc3 upon nc2 is nothing but, as I said, this n minus 2 is to be written first, n minus 2 is to be written first, and in the denominator of that this value of r, that is 3, and that whole upon, again same thing we will apply, this n minus 1 first we will write as per the formula, that upon this 2, and that is equal to half. So we can directly get this term in multiplication, as this is there in denominator. So this will become n minus 2 that upon 3, which is equal to this n minus 1 that into this 2 to the 4. So let's do the cross multiplication. So this is 4n minus 4 to the 8, which is equal to 3n minus 3 1 the 3. So we can get this 3n in left hand side. So 4n minus 3n is simply n. This minus 3 plus 8 is, this is positive 5. So the value of this n is 5. So that is there in option D. Let's start these two MCQs. Here in the first, this A1, A2, A3, A4 are coefficients of any four consecutive terms in the expansion of 1 plus x whole raised to n. And we have to find the value of this A1 upon A1 plus A2 plus A3 upon A3 plus this A4. For that, we will consider this formula TR plus 1 is equal to this NCR into this x raised to n minus r into this a raised to r. So in that formula, the value of x is here 1, and that of a we are going to put as x. So therefore this TR plus 1 will be equal to this NCR into 1 raised to anything is 1, and that value of a is here x, and that x raised to r. That means here the coefficient of r plus 1th term is always NCR. That means if I want to talk about the coefficient of 25th term, so that coefficient will be NC24. That means this number will be less than this number by always 1. So that you should remember. So we will assume those coefficients. Let A1, A2, A3 and A4 be coefficients of that r plus 1th, r plus 2th, r plus 3th and r plus 4th terms in the expansion of that 1 plus x whole raised to n respectively. As you can see here, the coefficient of r plus 1th term is always NCR. So here also the coefficient of r plus 1th term is going to be NCR. So the value of this A1 is nothing but simply NCR. Same about this A2. A2 will be equal to this NCR plus 1. So this A3 will be equal to NCR plus 2, and the value of this A4 is nothing but NCR plus 3. So let's substitute these values in this expression, whichever we want to find it out. So the value of A1 is NCR that upon this NCR plus this NCR plus 1, and the value of A3 is NCR plus 2 that upon this NCR plus 2 plus this NCR plus 3. So as we know this NCR plus 1 we can add, so we will use the formula. So that formula I am writing there. So that formula, whichever I was talking about, NCR plus 1 is always equal to n plus 1 CR plus 1. So these are two consecutive combinations. So here we can add using the same formula. So this denominator becomes n plus 1 CR plus 1. Same about second part. So this NCR plus 2 that upon this NCR plus 2 plus NCR plus 3 is nothing but n plus 1 CR plus 3. So again we will use one more formula. So that formula is NCR is equal to n upon r into n minus 1 CR minus 1. That is NCR is always n upon r times n minus 1 CR minus 1. So simply we have to write this n and r here, and we have to reduce the value of that n and r by 1 each. So we will apply the same here in the denominator. So that n plus 1 upon this r plus 1 I am writing as it is, and we will reduce those two values by 1 each. Similarly, this denominator will also become n plus 1 that upon this r plus 3, and this nc r plus 2. So this ncr plus 2, ncr plus 2, and this ncr get cancelled. So this is 1 upon n plus 1 upon r plus 1. We will write those terms in multiplication. So this is r plus 1 upon n plus 1, and here it is r plus 3 that upon n plus 1. So as their denominators are same, we can add their numerators. So 2r plus this is 4, and that upon n plus 1. So for some time we can take 2 common, and this will become r plus 2, and let this n plus 1 be as it is, and we will get that term in denominator, so that we can simplify it. N upon 1 that upon r plus 2 that became. So now for that we are going to write something. So we will consider this combination n plus 1 c r plus 2 is always written as this n plus 1 that upon r plus 2 into this. As I said, we have to decrease those two values by 1 each, so that will become like this. So if I want the value of that part, so that value will be this combination upon this combination. So that value I am writing here. So remaining part we will continue here. So this will become 2 upon, again you can see here the value of this n plus 1 upon r plus 2 is this combination upon this combination. So that I am writing this n plus 1 c r plus 2 that upon this nc r plus 1. So that value we substituted. So now you can write that in same in numerator. So that will become 2 times this nc r plus 1 that upon this n plus 1 c r plus 2. So again we can write this combination in denominator as sum of 2 combinations, as this is nc r plus 1 plus this nc r plus 2. So when we add those 2 combinations, we will get the same using the formula whichever I used earlier. So in the initial part you can see here the value of this nc r plus 1 is nothing but a2. So here we will write that a2. Again this is also a2, and this is nothing but the value of that a3. So from options, this part you will see in option number C. So C is the correct option. So let's continue this next MCQ. So that part we will write here again. So here we have to find the value of this particular expression. For that we will consider this as it is in the solution. So this nc1 into x into 1 minus x whole raised to n minus 1 plus 2 times this nc2 into x square into 1 minus x whole raised to n minus 1 plus, sorry, it is n minus 2. Again this is 3 times nc3 into x cube into 1 minus x whole raised to n minus 3 plus dot dot dot. So last term is given to be here, n into this ncn into x raised to n. So the same can be expressed using sigma notation or summation as here it is 1, 2, 3 and so on. Lastly it is n, so we can write that in general it is as r, and this r is changing from 1 to n. And second thing, the index of this x is again changing from 1 to n. So here we will write that as x raised to r again. And one more thing that is about combination is this nc2, here nc1, etc. Here it is. So we can write that as ncr, and 1 minus x whole raised to, here it is 1, then it is 2, then lastly it is n minus n is 0, that is 1. So we can write that as n minus r. So let's simplify the same here. So this summation r is from 1 to n. So let this r into this, okay, r into this x raised to r we are writing as it is. But for NCR again we will use this formula, NCR can be written as n upon r into n minus 1 CR minus 1. So this formula we will use here. So this is n upon r into this n minus 1 CR minus 1, and let this 1 minus x whole raised to n minus r be there as it is. So this r is going to get cancelled, and this n and x from that particular part we are going to take outside intentionally. I repeat, n and x from this term I am taking outside. Then the part which is left in summation will be that particular x raised to, here it is r minus 1, and this combination n minus 1 c r minus 1 and into 1 minus x whole raised to n minus r. Let this nx be as it is, and this part is nothing but x plus 1 minus x whole raised to this n minus 1. That means when I expand this using the formula x plus a whole raised to n, so we are going to get the same. So this nx into that x and this x is going to get cancelled, and 1 raised to anything is 1. So 1 into this nx is here nx. So this nx we can see here in option A. So option A is the correct one. Let's start this MCQ. Here we have to find the value of this summation. For that we will substitute this log of 10 to the base e as x for some time, just to simplify it. So let's continue. Put this log of 10 to the base e as x. So let's see how this expression is going to be. So this summation r is from 0 to n, this minus 1 raised to r into this NCR into this 1 plus r into log of 10 to the base e upon 1 plus log of this 10 raised to n can be written as n into log of 10 to the base e and whole raised to r. So this much is given. So now we are going to make actual change by putting this log of 10 to the base e as x here. So this summation and all those things remains as it is. So which is from 0 to n, this minus 1 raised to 0 r, and this NCR will be as it is, and here this is 1 plus r into that x and 1 plus n into this x whole raised to this is r. So now we are going to divide each term of this numerator by this 1 plus nx whole raised to r, and this is there in multiplication with both the terms. So see it here properly. So this is from 0 to n minus 1 raised to r, this NCR, and this 1 upon this part we will write 1 upon this 1 plus nx that raised to r, or we can write that whole raised to r also, plus again this summation r is from 0 to n, so this minus 1 whole raised to r, and this NCR again here also, that rx that upon this 1 plus nx whole raised to r. So now we will make change in the second term. So as you can see here properly, so this is nothing but the expansion of 1 minus this 1 upon 1 plus nx whole raised to n. So when you expand this, we are going to get this result, plus so we will make some change here. So this summation, so for NCR we can write that n upon r into this n minus 1 c r minus 1, and let this minus 1 raised to r be as it is, and so here r should not be 0, so we have to start that value of r from 1 and to that n as it is, and this rx upon this 1 plus nx whole raised to r remain as it is. Again we will make small change. Let this 1 minus 1 upon 1 plus nx whole raised to n be as it is. So now what we will do is we will take minus 1 common. So this minus 1 whole raised to r can be written as minus 1 whole raised to r minus 1 into that minus 1 raised to 1. So this minus 1 raised to 1, that is minus 1 we are going to take outside. So here it will be minus sign. That means one of the minus 1 I am going to get outside, and that summation is from 1 to n. And one more thing, this particular r and this r is going to get cancelled. We can take this nx outside. And second thing, so 1 plus nx that raised to r, out of those two 1 plus nx I am going to get 1 plus nx outside intentionally. So again this r is from 1 to n. So this minus 1 raised to will become r minus 1, as minus 1 of the minus 1 I have taken outside. So this r and this r has cancelled, this nx already I have taken outside. So this is minus n minus 1 c r minus 1, and it is 1 upon 1 plus nx that whole raised to, or simply 1 upon that nx whole raised to, it will be now r minus 1, because one of the 1 plus nx in denominator I have taken outside this summation. So let's simplify the second term first here. So this 1 minus 1 upon 1 plus nx whole raised to n as it is. So if you see here properly, so this is again nothing but the expansion of some term. So that term is going to be, so this, let this nx upon 1 plus nx as it is. So this part is nothing but the expansion of, so here alternatively plus minus sign is going to get. So here it is the expansion of 1 minus this 1 upon 1 plus nx, but here that whole raised to, it is going to be n minus 1. So this is same as that of previous term. So let's simplify it again. So 1 upon 1 plus nx that whole raised to n minus, so we can simplify here also. So this is 1 plus nx into 1 is 1 plus nx minus 1 ones are 1, that upon this 1 plus nx whole raised to n minus this nx upon 1 plus nx, and this is again same 1 plus nx minus 1 upon this 1 plus nx, and that whole raised to n minus 1. So this plus 1 minus 1 get cancelled. Simply it is nx upon 1 plus nx that whole raised to n minus, so look at this bracket, this is nx that upon 1 plus nx that whole raised to n minus 1, and here it is nx upon 1 plus nx. So when we multiply those two brackets, so these are the same brackets, but here the index is 1 and here it is n minus 1. So we can add their indices. So first term remains as it is, 1 plus nx whole raised to n, and here this minus 1 plus 1 get cancelled. Here also nx upon 1 plus nx that whole raised to n. So here those two get cancelled and simply it is 0. So this 0 you can find here in option number A. So this is the correct option.